Today we were talking about forecasting the weather. Weather forecasting, also called meteorology, is not easy. It's not easy to do, which means it's also not very easy to teach about. You've probably noticed this with news forecasts. They give you the 5-day forecast or the 10-day forecast. Often they're wrong on just the first day or the second day. It's not easy to forecast the weather. And we're going to talk a little bit about why it isn't easy. So we have a couple links that we're going to look at, watch a couple of videos, look at a couple weather maps. Just realize again that forecasting is not easy. The idea of trying to forecast the weather has been around for a really long time. In 650 BC, we have records of the Babylonians trying to use clouds to predict the weather. And you can't actually use clouds to predict the weather. Again, it's not going to give you a detailed forecast, but you can. Here's a little bit of an example with that. You see these clouds here, cirrus clouds. We've learned about those little wispy horsetail clouds. What that can mean is an approaching front and stormy weather. These clouds also you should be able to recognize cirrocumulus clouds. Those are fair weather, but cold usually, high-level ice crystals. These clouds you certainly know, cumulonimbus clouds, and you know what weather they bring. So heavy rain, thunder, lightning, hail, tornadoes. So if you see the cumulonimbus clouds approaching, you know what the weather's going to be like. Nimbostratus clouds, those are those low-level rain clouds. So widespread light to moderate precipitation. They accompany warm fronts, might have rain for many hours or a day. Cirrostratus clouds signal precipitation within 15 to 25 hours. These are leading ahead of the warm front usually. So you see these clouds and you can predict that within a day you're going to get precipitation. You're going to get these nimbostratus clouds with the light kind of moderate rain. And these clouds here, cumulus humilis, these are the fair weather cumulus clouds. It means you're not going to have precipitation. It's going to be a nice fair weather day. So you can definitely do a little bit of predicting just by looking at the clouds. If you're going backpacking or taking hikes or classes about backpacking, there's little guides that you can use that use the clouds to help you predict the weather for your backpacking trips. Also, you might have heard the saying, I have it right here, red sky at night, sailors delight, red sky in the morning, sailors take warning. This is another very old saying attributed to numerous people. Kind of most importantly maybe is Jesus in the Bible. In Matthew 16 verses 2 and 3, Jesus says this. And in the mid-latitude, so where we're located, this really does ring true because we're in the westerlies, so all the weather pretty much comes from the west to the east. So if you see this red sky at night, it's going to be not stormy weather. You're going to have clear night. If it's red sky in the morning, though, you need to take warning. And you can look, read more into it, but basically it's about the height of the clouds and the sunlight reflecting or scattering through the raindrops or the ice crystals up high in the clouds. So little things like that have allowed people to try forecasting, thousands of years ago. Now we're using mostly just observations. And I want to kind of show you these two videos. The first video is about using satellites for it. As I said, most of it now we're using observations, and these observations might come from, I'll put it up here, might come from weather balloons, Doppler satellites, we have Doppler radar, we have satellites in space. So we're using these observations, and we're trying to figure out what the next day might be in the next day. And in this third video, or the second video here, I like what the guy says in here, the meteorologist. He talks about if it's like this today, then it'll be like this tomorrow. If it's like this tomorrow, then the next day is going to be like this. So if you're wrong with day 1, it means your day 2 is wrong, which means your day 3 is wrong, which means your day 4 is wrong. So these extended forecasts of 5 days or 10 days get very, very difficult because if you make one observation wrong, everything else kind of snowballs after that. So let's take a quick look at these videos. First one about using satellites to help you predict the weather, and then just why is forecasting so difficult.
Weather is one of the most powerful, important forces on Earth. But how do you know what the weather is going to be like so you can plan ahead? A lot can go wrong if you don't plan for the weather. While you're busy with your everyday life, a global network of gadgets scan and measure the atmosphere, collecting data from all over the world. Radar systems, weather balloons, ocean monitoring buoys, and lots of other cool instruments track changes to help predict the weather. Another vital ingredient is space. Way out in orbit, weather satellites are getting the big picture of atmospheric changes. These European weather satellites, METOP and Meteosat, give us the ability to see the weather before it reaches us. Orbiting the Earth 14 times a day, around 850 kilometers up, METOP keeps a close eye on temperature, humidity and winds. METOP's observations, along with all the other data, are fed into powerful supercomputers. These huge machines then crunch their way through millions of bits of data about current weather, oceans and atmosphere to forecast future weather. The process is called numerical weather prediction and is what scientists use to help us plan our lives. It's clever stuff. Individuals and entire countries can react when bad weather is on the way. Governments, pilots, farmers, fishermen and sailors, shop owners, tourists, building workers and even power stations all rely on accurate weather forecasts. Further out in space, at 36,000 kilometers, Meteosat stays over the same spot on Earth, keeping a 24-hour watch over Europe and Africa's weather. This type of satellite is essential for detecting the development of rapidly changing weather, such as storms or fog, helping meteorologists work out what is likely to happen in the next few hours. So many lives are affected in huge ways by the weather, and our ability to predict and plan for it. And everyone's life is affected in little ways every day. Weather forecasts enable us to plan to keep traffic moving, planes on schedule and on the safest path. And everyone's day, well, not always without a hitch. So remember that a whole host of satellites and other amazing weather technology are always at your fingertips whenever you have plans. So don't forget to check the weather.
So again, the big thing to get out of there is it's about observations. The more accurate and detailed observations we can make, the more data we can feed into these supercomputers now. They can run through the processes, see what happened when these situations were similar the last time or other times in the past, and then make those predictions of what the weather's going to be like, whether it's hours in advance or days in advance. Let's move on to the next video and we'll just watch a few minutes of this one.
Forecasting is probably the hardest thing we have to do because those are the events that people remember. If you blow the snowstorm and you say 20 inches in New York and it's 20 inches in New Jersey instead, people only remember that you said 20 in New York and it didn't happen. We have computer models that literally try to forecast what's going to happen, and then we believe those models. If the models are wrong, we're wrong. The problem with the models are that you can't put all the data in, or if you had everything in the world into the model, it would take you 4 days to make a one-day forecast. Right now, one of the models that we use, the best model in the world, has 22 layers. 22 layers of the atmosphere. Think the layers of the atmosphere, think are 22. No, there's an infinite number of layers of the atmosphere. We have to break it down to 22. The parameters of the weather model are fast.
We have temperature at the ground, we have temperatures in the mid-level, temperatures aloft, how big the jet stream is, what the humidity is, what the wind direction is, what the water temperatures are, where the mountains are, where the low pressure is, where the high pressure is. All of those factors fit in. And so what we have is a model that says, if this today, then this tomorrow. And then, if this tomorrow, then this the next day. And if the first day is wrong, all the way down the model's wrong. The computer models we use are great at forecasting large areas, like the size of a state. The problem is many models and many events that you remember happen within a few miles, where the rain changes to ice, changes to snow right over your city. So Toledo, it's raining, and Mount Clemens, it's snowing, and somewhere in between in Detroit, there's a hailstorm or an ice storm. So that's what the models don't do well. They don't make small changes in small areas. Irene was forecast to be a very big storm, and it was a storm, and it killed many people away from the big city. Well, everybody, all the media focused on the big city, focused on New York City, because that's where people live. Well, the storm didn't really hit New York City with a lot of vengeance, but the storm still had potential. So we couldn't let it down. When Irene made landfall, it had the same pressures as storms like Charlie, Francis, Jean, Wilma, Ivan. All of those storms, all of those names are retired because they were major disasters. And Irene will be a major disaster. It just didn't hit New York City like some of the forecasts were saying. And so that's all the people of New York City remember. Oh, look what they said, and look what happened. Well, talk to the people in Vermont, see if they think it was under forecast. As a meteorologist, whether you're on TV, working for the hurricane,
And we'll stop there. But again, you get the idea. It's this idea of we need the accurate observations. It's where the jet stream is. It's the humidity. It's the wind. All those things that we've talked about for this unit. And then once you have all that data, you feed it into the computer, we can make that prediction. If it's wrong for the first day, second day forecasts are going to be even worse. Then it's going to kind of compound like that. So we look at weather maps, like you see up in here. And again, we went over all these symbols. The cold front is the blue line with the triangles. L's are for low pressure. We have our warm fronts, everything like that. But if you're making a prediction, you know which direction this cold front's going. You see right now, it's sunny in, I guess El Paso's down here, but sunny around this area. So Dallas would be sunny and in the 90s. But the next day, what would it be? Well, you see, you're looking ahead, okay, that's a cold front. If you've watched it for a couple days, you would know how fast it's moving. So let's say it's moving, 20 miles per hour, 30 miles per hour. You can then map that out to see, okay, it's going to come through Dallas at around this time. Well, guess what? If it speeds up, you're going to be wrong in your time. If it slows down, you're going to be a little wrong in your time. But that's what we're doing, is we're seeing where these things are coming from, how fast they're going, what the temperatures are like behind them there. If it's 75 for a high behind it there, by the time it gets down to us, maybe it's going to be, an 80 for a high or 77 for a high. It's going to definitely be cooler than the 93 or so that Dallas would be now. But it's just about prediction. And again, we're in the westerlies, so pretty much everything is going west to east. So in Dallas, or if you're somewhere on the East Coast, you have that luxury of having all of this United States in front of it. Imagine if you're in San Francisco or Los Angeles, you're somewhere on the West Coast, to the west of you is the ocean. You don't have as much data as you do for somewhere in the Midwest or in the East Coast. So we've got a lot of data, so our predictions are a little bit better because we can see these things coming. Just a little bit more on the weather maps. Again, you see a weather map like this with the low pressure, the cold fronts, warm fronts, high pressures. You see these lines. Remember, these lines are called isobars. They tell you what the pressure is. So 968 or 986, whatever that says, is definitely low pressure. 1020, definitely a high pressure. You see the winds. The winds are spiraling into the low. Again, you could predict which way the winds are going to be based on the proximity to the low pressure area. So if you're down here, you know they're going to be coming kind of from the southward area, southeast, south, something like that. If you're over on this side, you know they're going to be coming from the north or northwest or westward because they're all going to spiral in. So you can make prediction based on you knowing that winds spiral into a low pressure. You can make predictions about the high pressure because you know winds spiral outward and to the right from high pressures. So you can make predictions like that too. The weather map signals here, we talked about those before. We don't really need to cover those in this. It's not really much about forecasting. And again, we just see more with this. And again, everything in the United States mainly is moving west to east. I put this picture down here because it's someone we haven't talked about a lot, but it really is a factor mostly in Texas, and it's this yellow line here. It's not one of our main fronts. It's not the cold front or the stationary or the warm or the occluded. This is the dry line. Okay, this is a dry line. It's really big in Texas, also Oklahoma. Before I moved down to Texas, I had never heard of what the dry line was. And I get down to Texas, and during the springtime especially, it's always talking about the dry line. Where's the dry line going to be? Is it going to be on top of Dallas? Is it going to be to the west? Is it going to be to the east? That dry line is a big factor in predicting the weather in Texas. Basically, you think about what a dry line is, it kind of the name makes sense. It separates dry air from moist air. So the dry air is the dry air is behind it. The moist air is in front of it because the Gulf of Mexico is here. Okay, so you have the warm Gulf of Mexico. So this is all really moist air. We have the cold front coming with this dry line. So the dry line separating the dry from that. When that cold front comes and it hits that dry line, what it's going to do, if you remember from our cold front lesson, it's going to force this air straight up, and it makes cumulonimbus clouds and bad thunderstorms and rain. So if we have really moist air, when that air rises up, it's going to make really big thunderstorms and really violent weather. So being able to predict when this dry front or dry line and the cold front meet and where they meet is going to be really important. I said, and that's where kind of the last video was saying that this, a few miles, you want to know, is it going to be in Dallas? Is it going to be Fort Worth? Is it going to be Plano? You want to know kind of the exact location. Right now, it's really hard with the computer models to do it that specifically. You know it's going to come in, you know it's going to be somewhere in the area, but you don't know exactly where. The more observations that we get, the more practice, the more stuff we can feed into the computer models, the better we're going to be getting with these. So that's my little kind of summary about forecasting. Again, the main message is it's not easy. Meteorology is not easy, and we do the best we can, but the better observations we have, the better computer modeling software we have, the better we'll be.